Good day everyone, my name is Yew Wan Qi and I'm from 4SAJets. Today I will present my technical report with the title Processor Utilization Analysis of Real-Time Flood Monitoring and Warning System. First, I identify 5 concurrent tasks from my project 1. After getting the project task set, I suggest a reasonable period and the worst case execution time for each task. Here is a table that shows the concurrent task set with the period and worst case execution time. Next, I calculate each of the tasks by using the basic processor utilization analysis approach. You can see on the right hand side here, both of these equations will be used to calculate the data and analysis whether the task set is schedulable. In here we can see that these 3 tasks are schedulable because if all the task total utilization is smaller than the worst case schedulable time bound for each task. Next, in the task file stormwater deep, you can see that the task utilization is larger than the worst case schedulable time bound. Hence, this task is not schedulable. From here, we can conclude that this task set is not schedulable. Next, I'm going to share the 3 tools I chosen are times, trader, and mass. In here, I will just explain the tool I selected, trader. The main provider of this trader is scheduling simulations, support aperiody and cycling tasks, extract the information from the scheduling simulations, and last, fast approve to create the user-defined schedulers to simulate the precise scheduling of ad hoc applications or systems. Compared with the mass and time tool, trader is a tool that easily for us to perform the schedulability test approve, including the processor utilization analysis. The task information such as the processor utilization factor and missed deadline will be provided by the trader after simulations. In addition, trader also able to generate the timeline to show how the task will be scheduled. Now, I'm going to demo how to use the trader to perform the processor utilization analysis approve. This is the result I get from the trader. Next, I'm going to share the enhanced processor utilization analysis. The paper 1 I choose is improved processor utilization with a task classifications model-based application specific hard real-time analysis architecture. The second paper is a utilization-based schedulability test of the real-time system running on a multi-processor virtual machine. In paper 1, the author stated that the considerable technological advancements allowed the next microprocessor generations to increase the computational capacity and normalize memory access time, however, were unable to keep with the rising processor performance. The hard real-time system design must also take the worst-case scenario into the account. As a result, the real-time systems are typically overbuilt and do not benefit from the advancements in the field of standard processor. Next, in the paper 2, the problem is need to identify and avoid the down effect. The down effect is some tasks that may be unschedulable even though they have the lowest utilization. Additionally, even for the system with the low multiprocessor utilization, down effect demonstrate that a direct implementation of the RM priority assignment machine may result in the missed deadline. So, for the paper 2, the author proposed a quick utilization-based scheduling ability test for the real-time system operating on a multiprocessor virtual machine. The solution able to avoid the down effect and guarantee all the tasks that will be low with the low utilization are schedulable. In order to avoid the down effect, the tasks need to be classified into the 2 priority classes, light tasks and also the heavy tasks. The result of select the solution in paper 2 is because the paper 2 provide a detailed solution and algorithm on how to enhance the processor utilizations. In addition, compare the 2 methods used in the paper. the method in the paper 2 is more specific for us to use in the case study. Here show the calculation step for the task 1. From here we can see all the data able to obtain by using the equations given in the paper 2. Look at the figure 3 here. We can conclude that the task 1 is line task and schedulable since the threshold value is equal to the utilization of the task. This is a summarized table for my case study task set. From here we can conclude that the task set is schedulable since all the tasks is schedulable. Now I'm going to share about the discussions. When applied the traditional approach for the task sets, the result we get is not schedulable due to the task 1 is not schedulable. After we apply the enhanced approach selected from the paper 2, the task set is schedulable. Compared with the paper provided, we use different schedulability test-based approach to prove whether the task set is schedulable or not. In paper provided, the actor used the response time analysis approach, but in our case study, we use the processor utilization analysis approach. Compared to the result of using the basic approach, the processor utilization of our task set is not schedulable. In contrast, in the paper provided, the response time of the mobile robot 1 task set is schedulable. After we apply the enhanced approach found in the paper 2, the task set is in our case study becomes schedulable. Compare this result with the paper provided, we can conclude that the both systems had meet the deadline since both results are schedulable. That's all from me. Thank you.